My dear students, in our previous video, we solved some problems in the exercise 3.3. Now, in this video also, I am going to continue the same exercise. The only last two problems are remaining in this exercise 3.3. Problem 11 and 12 are two problems of objective type problems. So we will see one by one from this video. In the exercise 3.3, problem number 11. If A and B are two symmetric, if A and B are two symmetric matrices, of same order. If A and B are two symmetric matrices of same order, then AB minus BA is a, four options are given: symmetric matrix, geosymmetric matrix, zero matrix, and like that. Some four options are given. If A and B are two symmetric matrices of same order, then AB minus BA is Q symmetric, zero, identity. Four options are given. Now, since the matrices A and B are symmetric, since the matrices A and B are of symmetric matrices of same order, we know that since A and B are symmetric, then A equal to A dash and B equal to B dash. That is the property of symmetric matrices. A equal to A dash and B equal to B dash. Because A and B are symmetric matrices. This is the property. A equal to A dash and B equal to B dash. Now, since what is AB? We have to prove that AB minus BA. So, what is AB dash? We know that AB dash, by the property of transpose of the matrices, AB dash is equal to B dash into A dash. So, AB dash equal to, by transpose of AB dash, AB the whole dash is B dash into A dash. B transpose is B, A transpose is A, because A and B are symmetric matrices. Therefore, A equal to A dash and B equal to B dash. Therefore, B dash equal to B and A dash equal to A. Therefore, instead of BA, in the question is AB minus BA equal to, instead of BA, I can write AB minus BA. Instead of BA, I am writing AB the whole dash, AB transpose. So, we know that A minus A dash. We know that A minus A dash is a Q-symmetric matrix. Therefore, AB minus BA equal to AB minus AB dash by the property of transpose of the matrix. A minus A dash is Q-symmetric. You know, therefore, it is equal to Q-symmetric. Q-symmetric. This is option A, I think, in the question, option A. Because reason is A minus A dash is Q-symmetric. A minus A dash is Q-symmetric. Therefore, AB minus AB dash is Q-symmetric. Hence the problem. Next, 12th problem. 12, if a matrix A is given as cos alpha minus sin alpha, cos alpha. This is the matrix A given. And the condition is also there. And A plus A dash equal to identity of order 2, I2. 2 by 2 matrix. Therefore, I2, A plus A dash is I. Then the value of alpha is, then the value of alpha is, 4 options are there. That is 5 by 6, 5 by 3, 5 by 6, B, 5 by 3, pi 3 by 2, pi 3 pi by 2. These are the 4 options given. What is A plus A dash? You know A is cos alpha minus sin alpha, cos alpha. This is A plus A dash is interchanging the rows and columns. Cos alpha, sin alpha. Cos alpha, sin alpha, and minus sin alpha, cos alpha. Minus sin alpha, cos alpha. This is equal to given as I. I mean identity matrix of order 2, 1, 0, 0. This is I. This is the condition. If it is a condition, find alpha. Now adding this to cos alpha plus cos alpha is 2 cos alpha. Minus sin alpha plus sin alpha is 0. Sin alpha minus sin alpha is 0. Cos alpha plus cos alpha is 2 cos alpha. Which is equal to 1, 0, 0, 1. So, element wise you have to compare 2 cos alpha equal to 1. Therefore, from this, 2 cos alpha equal to 1. Therefore, cos alpha equal to 1 by 2. This implies alpha equal to, since cos alpha equal to 1 by 2, alpha is 60 degree, cos 60 is 1 by 2. Therefore, 60 is nothing but 5 by 3. 5 by 3 is second option B. So, alpha is 5 by 3. That's all about the problem. Next, we are going to study a new topic, elementary operations on matrices. We will see. That's all about the exercise 3.3. Alpha is 5 by 3. Now, the next idea. Elementary operations. Elementary operations on matrices. These operations are also called transformations. These elementary operations are also called transformations. 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 Elementary operations on matrices. This is nothing but transformation. There are some 6 operations, elementary operations on matrices we are going to see. Out of the 6 operations, 3 are row transformations and 3 are column transformations. Suppose you consider a matrix A by A, B, C, D, E, F are real numbers you have to write. Instead of writing the letters, I just write 1, 2, minus 0, 4, 3, 2, 1, minus 2, 5. You consider a matrix of order 3 by 3. Elementary operations means we have 3 operations on rows and columns. There are 3 operations on rows and 3 operations on columns. First one is any 2 rows and columns of a matrix are interchanged. That means you know this is first row and this is second row and this is third row. This is R1 and second one is R2, third one is R3. And this, similarly this matrix, that is column 1, column 2, column 3. Like that, this is 1, 2, minus 1, 0, 4, 3, 1, minus 2, 5. Like that. Given matrix A, this is R1, R2, R3, C1, C2, C3. For example, I am giving row operations, any 2 rows and columns are interchanged. But with row operation, R1 and R2 are interchanged, means R1 goes to R2 and in turn R2 goes to R1. This is one operation. R1 goes to R2 and R2 goes to R1. That means R1 and R2 are interchanging. Any 2 rows and columns are interchanged. A column means C2 goes to C3 and C3 goes to C2. C2 and C3, these 2 are interchanged. First one is row R1 comes to R2 and R2 goes to R1. Like that, the operations. Rows, first set is any 2 rows or columns are interchanged. Second one is, this is second set, I mean, the elements of any row or column are multiplied by a non-zero number. That is, R2 is some 5 times of R2. Any row, the elements of any row or column are multiplied by a non-zero number. That is positive number or negative number. The R2 implies 5 times of R2. So the elements of R2 are multiplied by 5. They are non-zero number. Similarly, column. The column C1 is multiplied by minus 2 times of C1. Like that. C1 column number. First column elements are multiplied by minus 2. Like that, the second set of operations. The transformations are, first set is any 2 rows or any 2 columns are interchanged. And the second one is the elements of any row or the elements of any column are multiplied by a non-zero constant, non-zero number. And third one is the elements of any row is the elements of any row, the addition of elements of any row with the elements of the corresponding elements of any other row and multiplied by a non-zero number. That is, the elements of any row, addition of elements of any row with the elements of any other row multiplied by a constant. That means R1 is R1 plus 3 times of R2. The elements of R1 added with the elements of R2 and that elements are multiplied by a non-zero constant 3. Any elements of R1, addition of the elements of R1 with the elements of R2 multiplied by a constant 3. This is another operation. Similarly, for column, any elements of column C2 is C2 plus 3C3. The elements of the column number 2 adding with the elements of the column number 3 by multiplying a constant 3. Also the same constant you need not write, that is some other minus 3, 4 or 1 by 5 also. Fraction also you can multiply. The elements of the columns of 2 are adding with the elements of columns of 3 multiplying by the constant 1 by 5. That means the non-zero number 1 by 5. These are the 3 sets, totally 6 operations they are saying in your book. But 3 operations on rows and 3 operations on columns, totally 6 operations. These operations are called elementary transformations or elementary operations on matrices. You remember, using these operations, we are going to find out another concept, that is invertible invertible matrices. See, up to this, using this idea, we are going to introduce another concept, invertible matrices. That topic, invertible matrices, we will see in the next video. Okay, we will stop here and we will continue in the next video, the topic invertible matrices. Thank you.